What is it that makes us human? That gives us the ability to reflect on the past and ponder the future? Who we are as a species and where we came from make up the basis of a fantastic story, spanning more than 4 million years. I'm Don Johansson, and I'm one of the many researchers dedicated to discovering and interpreting the evidence for human origins. Evidence that provides the framework for the human story. It's a story that begins in Africa, where our ancestors first stood up. Over millions of years, they continued to evolve and eventually spread out across the globe. Some species adapted to the changing world, while others went extinct. Today, only a single species of humans survives. That species flourished because they developed a culture more complex than has ever been seen before. This is their story. This is our story. Hadar, Ethiopia is a place of pilgrimage for those of us who study human origins. It's located in the northern Afar region of the country and can be inhospitable at times when temperatures reach 125 degrees. My first trip to Hadar in 1972 was a short exploratory trip, but I was there long enough to realize it was a place I was going to do fieldwork. Hadar had the right kind of geology and was very, very rich in animal fossils dating to about 3 million years. And I thought to myself, if we could find hominid fossils in deposits this old, we might just open up a new chapter in human evolution. In 1973, I made my first fossil hominid discovery, a knee joint. The specimen came from a geological stratum dated to nearly 3.4 million years. Detailed study of the functional anatomy of the knee showed beyond a shadow of a doubt that it was from a creature that walked upright, a hominid. Then, in 1974, we returned to Hadar, and in late November, near the end of the field season, I made a discovery that firmly placed Hadar on the map as one of the most significant hominid fossil sites in the world. I remember very clearly it was about noon, and I'd been surveying since just after breakfast. The temperature was approaching 110 degrees, and I hadn't found much except a few teeth of a horse, part of the skull of an extinct pig, some antelope molars, and a bit of a monkey jaw. But as I turned to leave, a fossil caught my eye, and I kneeled down for a closer look. It was, in fact, part of an elbow. As I looked further, I saw another bone, and then another. It was truly unbelievable. What I had found was a partial skeleton eroding from the ancient Hadar sediments. I knew immediately it was a hominid, a very old one, and astonishingly complete. That night in camp, we examined the fossils, and in the background, the Beatles song "Lucy in the Sky with Diamonds" played over and over on a small tape recorder. Because of the petite stature of the skeleton, I suspected right from the start that it was a female. At some point during the evening, the new fossil picked up the nickname Lucy, and she's been known as Lucy ever since. Her discovery did indeed open up a major new window into the study of human origins. Until the discovery of Lucy, there were few hominid fossils dating back to more than 3 million years. So Lucy, at 3.2 million years, now offered many new insights into our ancestral past. Because of her unique anatomy, we dubbed her and the other Hadar fossils a new species, Australopithecus afarensis. Australopithecus means southern ape, and Afarensis celebrates the Afar people in the region where Lucy was discovered. In terms of her relationship to other hominid species, we suggested that Afarensis was the last common ancestor to all later branches of human evolution. Although today more complete skeletons and older fossils have been found, Lucy remains the benchmark by which all other human ancestor fossil discoveries are judged. She was the ape that stood up, and as it turned out, the woman who shook up man's family tree, all rolled into one spectacular find. In many ways, she's led the research in Ethiopia. She provided the catalyst for other expeditions, which continue to uncover an ever-increasing number of important hominid fossil finds, assuring Ethiopia's critical role in understanding human origins. It seems, no matter what we find, Lucy continues to be an extraordinarily important discovery in human evolutionary studies. Kay Reed is a researcher at the Institute of Human Origins and a professor in the Department of Anthropology at Arizona State University. As a paleoecologist, Reed attempts to reconstruct the environment in which our ancestors lived.
Hadar today is a very barren, dusty place. There's very little rainfall. 3 million years ago, we know that there were lots and lots of browsing animals, which means there are lots and lots of trees. And these trees probably extended from the ancient Awash River for miles. You could see fruit trees, dates and figs, and things for monkeys to eat, and more importantly, things for the hominids to eat.
Reed works with the local Afar people and collects the remains of many animal fossils found in association with the hominids. The Afar are the guides and the guards, and without them the work at Hadar would be impossible.
We worked with the local Afar people to show them what kind of fossils that we're looking for. And we do this by taking fossils that we've found previously and showing them, for example, a carnivore tooth. It's long and it's narrow and it slices meat. And we show a lot of different fossils this way so that when we're out looking for fossils, they know when they find something that's important that they can call and say, this is a cat, or this is a hippo, or whatever it is they find.
Every type of fossil we find contains valuable information. And knowing what processes affect the preservation of bones between the time of death and the moment of discovery millions of years later provides valuable insights into the world of our ancestors.
We do a lot of what's called taphonomy, which is the study of the laws of burial, or how animals got into the deposits in the first place. In an average fossil assemblage, bones accumulate over a long period of time, sometimes thousands of years. Specific marks on bones, environmental exposure like weathering or rolling in water, provide clues into what might have happened. Many of the fossils found at Hadar show different signs of trauma. Carnivores have chewed many of the bones collected here, and they've also chewed many of the hominid bones. And the fossil record indicates saber-toothed cats, hyenas, and lions were found at Hadar. Now, Lucy didn't have big canines like a baboon, and she didn't have stone tools or fire for protection. You have to remember that Lucy stood less than 4 feet tall and was a biped, so she probably didn't have much defense against the power of these huge carnivores. I think the fact that Lucy had fairly long arms was a benefit that allowed her to climb a tree and get away from these predators. If our early ancestors were sitting on the ground and they saw a hyena loping towards them and there were no trees to climb, they certainly would not have survived.
There seems to be magic in the fossilized bones of our ancestors that transcends time. And specimens like Lucy become touchstones for discussing human origins. In 1871, naturalist Charles Darwin, working without the benefit of the fossil record or modern genetic research, proposed that humans and African apes must have shared a common ancestor. Today, thanks to a variety of anatomical and molecular studies, we know that our closest living relative is the African chimpanzee. Incredibly, our two species share about 98% of the same genes. But this close relationship doesn't mean that we evolved from chimpanzees, nor does it mean that chimpanzees will evolve into humans. What it does mean is that millions of years in the past, we shared a common ancestor. As we journey back in time, our ancestors begin to look less like us and more ape-like. The fossil record gives us some important clues about where we come from. 8 million years ago, during a period known as the Miocene, a major portion of the African continent was covered in lush forests. A great diversity of apes thrived in these forests, feeding, sleeping, and easily navigating this world above ground. Evolutionary adaptations in their anatomy, such as grasping toes and joint mobility in arms and shoulders, made the apes extremely successful animals in this arboreal environment. But beginning about 6 million years ago, the world became a much drier and colder place. The African forests, home to the Miocene apes, started to thin and were gradually replaced by open woodlands. Although most of the ape species went extinct, in time a few began to adapt to the newer climate. One species that survived was the common ancestor of the African apes and humans. Three and a half million years ago, at the beginning of the rainy season in what is now Tanzania, a volcano we know as Sadaman erupted. The eruption covered the surrounding landscape with an ash that was fine and gritty, much like beach sand. And then it rained. The moistened ash from Sadaman became a type of natural cement, recording the tracks of many animal species who walked across it that day. Monkeys, rhinos, giraffes, and incredibly, two of our own ancestors, hominids. They were probably from Lucy's species, Australopithecus afarensis. Unearthed in 1978 by Mary Leakey and her excavation team, the Laetoli footprints are unique and dramatic evidence for one of the defining characteristics of being a hominid, bipedalism. Walking upright requires a unique set of anatomical features, and one of the most obvious features is the structure of the human foot. Unlike chimps, who have a divergent big toe used for grasping, the human big toe is in line with the other toes and helps to propel the body forward. The human condition is clearly preserved in the Laetoli footprint. To better understand the origins of upright walking, we need to look even deeper into our ancestral past. Nina Jablonski, curator of anthropology at the California Academy of Sciences, is a paleoanthropologist who studies bipedalism.
When you watch chimpanzees or gorillas interact with one another, they occasionally make bipedal displays in front of one another. Usually they do this when there's some kind of competition for resources among them. As soon as animals begin to be more bipedal, there are so many other things that they can then do with their forelimbs and hands. This is exactly how we think bipedalism evolved. And so a whole host of positive feedback mechanisms, the use of hands in feeding, in carrying, in play, in gesture. All of these things would feed into this system and propel bipedalism into a firm anatomical adaptation.
Recent hominid fossil discoveries in Kenya by paleoanthropologist Meave Leakey at the site of Kanapoi near Lake Turkana have provided even older evidence for bipedalism. Roughly 1 million years older than Lucy, Australopithecus anamensis was even more ape-like. However, the anatomy of the shin bone indicated an upright posture and gait. So bipedalism was the initial feature that set us apart from the apes. But it wasn't until much later that evolutionary changes would set our own genus Homo apart from the Australopithecines. The hominid fossil record between 2 and 3 million years is frustratingly sparse. Yet, by roughly 2 million years ago, fossils assigned to Homo make an appearance. However, today, there is little agreement as to how many species of Homo actually existed. By about 1.8 million years ago, we encounter a hominid, Homo erectus, that stands in contrast to all earlier ancestors. The skeletons of this species were larger and built more like our own. And most importantly, their brains were significantly larger. Alan Walker teaches anthropology at Penn State University and conducts field research in Kenya.
The brain size, body size is interesting because a large brain is one of the hallmarks of ourselves. It turns out that the easiest way to get a big brain is to get a big body. Brain size and body size are intricately linked, and it's a complicated linkage.
In 1984, near Lake Turkana in northern Kenya, Alan Walker and Richard Leakey uncovered the most complete fossil skeleton of Homo erectus ever found. Dated at roughly 1.5 million years, this is the skeleton of a young male, probably about 9 years old. Nicknamed the Turkana Boy, he stood about 5 feet 4 inches. But as an adult, he would have been at least 6 feet tall.
Homo erectus not only had big brains, they had big bodies. And the stuff they left on the archaeological sites shows us that they were eating animals. And we suspect that they were catching them too. There are consequences to becoming a carnivore. Carnivores eat meat, and meat is meat wherever it's found. Whereas herbivores eat plants, and individual herbivore species are matched to their plant communities. Carnivores aren't like that. Carnivores have huge home ranges, so the Homo erectus is pushing its own range further and further and further away from the ancestral home range by little territorial increments, and the pressure that pushes it are the numbers of Homo erectus that are still there in the ancestral homeland. This is not a migration in the sense that songbirds migrate south in the winter. This is a dispersal of a species.
About 1.5 million years ago, Homo erectus left Africa and began to populate the rest of the globe. In a sense, Homo erectus was the evolutionary parent of our own species. They carried with them not only advances in culture, but indelible assets that began with our earliest ancestors. With a bold, confident stride, Homo erectus crossed the threshold into a new world. In August 1856, workmen digging in a limestone cave called Feldhofer in Germany's Neander Valley uncovered the fossil remains of an unknown creature. At first they thought the bones were those of an ancient cave bear, but a local naturalist identified them as human. The Feldhofer cave yielded an impressive selection: the skull cap, bones from both arms, part of the pelvis, and fragments of the shoulder blade and ribs. Some of the bones looked strikingly different from those of modern humans. The arm bones were heavily built, and large brow ridges protruded above the eye sockets on the skull cap. Geologist William King recognized the distinct anatomy of this specimen from the skull cap. Even without facial bones, he decided these fossils fell outside the range of modern humans. In 1864, King named the new species Homo neanderthalensis. When you say the word Neanderthal, people automatically picture a brutish caveman shuffling around with his knees bent holding a club. Yet it would be wrong to think of the Neanderthals as a primitive, less evolved version of modern humans. For over 200,000 years, they were a well-adapted, highly successful species in their own right. They probably evolved in the cold periglacial climate of Europe, which remained the center of their range thanks to barriers of geology and climate. During the 20th century, dozens of sites across Europe and Western Asia have yielded hundreds of Neanderthal fossils. Their relative isolation in this region allowed the Neanderthals to evolve a unique set of behaviors and anatomy that sets them distinctly apart from modern humans. Ever since the discovery of the first Neanderthals, anthropologists have wrestled with what might seem a simple question. Were they one of our direct ancestors, or were they a side branch that went extinct without contributing any of their genes to modern humans? Paleoanthropologist Ian Tattersall of the American Museum of Natural History feels strongly that the fossil bones give us the answer to that question.
Neanderthals are distinctly different from modern humans, particularly in the structure of the face and in the structure of the brain case. The Neanderthal skull was long and low instead of being high and short the way the skull of Homo sapiens is. Homo sapiens has a little face that's tucked underneath the front of the skull. The Neanderthals had a big face that protruded in front of the skull. All through the body skeleton, there are distinctions between them and us. We're closely related species, but we're very different species.
Kathy Willermet, a PhD candidate in the Department of Anthropology at Arizona State University, is researching Neanderthals and has a different idea on their status.
No one is suggesting Neanderthals evolved into modern humans. What we're suggesting is that Neanderthals were an ancient population that blended with early modern humans moving into the area. Over time, the population of Neanderthals as a distinct population went extinct, although Neanderthal genes have continued on and may be with us today. At the very center of the Neanderthal range is a site called Vindiha in Croatia. At this site, we see several Neanderthal occupation levels spanning thousands of years. In the early Neanderthal levels, the fossil evidence shows your typical classic Neanderthal features. But in the later levels, we find something very interesting. The Neanderthals are showing facial features that look very much like early modern humans. And this suggests to me they are interbreeding with early modern humans.
Neanderthals had been very, very successful throughout Europe and Western Asia for a couple of 100,000 years, and then they suddenly disappeared. And it's very difficult to imagine that the Neanderthals became extinct for any other reason than that Homo sapiens came on the scene. Exactly what happened, I don't know. It's possible that there was direct conflict. It's possible that Homo sapiens triumphed in an ecological, in an economic kind of conflict. But one way or another, Homo sapiens arrived and the Neanderthals departed. And there's surely a causal relationship between these two things.
There is no evidence of any actual conflict between Neanderthals and early moderns. The superior modern technology like bows and arrows and spear throwers don't show up until much later. Neanderthals were successful for a very, very long time. Their behavior is very similar to ours in terms of they buried their dead, they had fire, complex tools, shelter, clothing. Whether they are a different species from us or their genes are still around today, the fact is that they're a very compelling, interesting group of people. We want to know what happened to them.
If Neanderthals were a separate species that did not interbreed with modern humans, they should have distinctly different DNA sequences. Anthropological genetics is in its infancy, but DNA sequences have been reported from 4 Neanderthal skeletons. In each instance, the Neanderthal DNA is distinct from that of modern humans, prompting some scientists to conclude that Neanderthals went extinct without contributing to the modern human genome. Stretching the length of the central coast of southern Australia is a desolate region known as the Nullarbor Plain. Today this land is flat and treeless, and it's largely lacking in visible signs of water. This is the last place you would expect to find evidence of early human activity, yet this place is sacred to the Australian Aboriginals, whose people have lived here continuously for the last 40,000 years. This entire region is full of connected caves that were formed by acidic water percolating through the limestone. Sinking 200 feet below the parched and dusty landscape, Cunalda is one such cave that was once used by our ancient ancestors. Over time, the cave became a place for personal expression. In this smaller, darkened room, every inch of the soft limestone walls within reach of human hands has been finger-incised into a meandering series of swirling lines. These first human impressions have been dated to about 24,000 years, making them older than almost all the fabled cave art found in Europe. These engravings are simple, yet they represent a profound change in the way our ancestors viewed the world. They mark the birth of their ability to understand abstract concepts, both about their world and about themselves. This was the dawn of consciousness. In another remote corner of Australia called Arnhem Land, researchers are documenting later examples of prehistoric art. Peggy Grove is a cultural historian and a specialist in Australian rock art.
Arnhem Land is a land of huge stone escarpments. And by that I mean there are stones piled on top of each other in these giant ridge lines. And the water pours down through them in the wet season, and it bakes them in the dry season. But they make perfect canvases for the Aboriginal artists to paint on.
Since many of the sites are considered sacred, Grove and her colleagues can't use traditional dating methods that might damage the art. Instead, they use changes in artistic style and the environment over the last 50,000 years to date the art.
Unlike European rock art, where most of the images tend to be animals, in Arnhem Land, at least 90% or more of the figures tend to be the human female. And I think this is environmentally predicated because it's an area that is very fertile and there is an immense amount of plant life. So therefore, the image that was chosen to be portrayed on the walls tended to be that of the female.
While the cultures that produced European cave art ended 20,000 years ago, in Australia the stories never stopped. Even today, Aboriginal people still learn about their ancestors and hone their artistic skills by interacting with the rock art of former generations. This is a living cultural record, one that stretches from the distant ancestral past right up to the modern era.
There are sites where there are handprints juxtaposed with images of steamships, with images of rifles. These are a form of communication telling us about the world around the Aboriginal artists at that time. They were documenting the influx of the Europeans coming into their land.
In other parts of the world, modern investigators are looking more and more to living cultures of Australia for clues about the meaning and techniques of ancient rock art. Michel Leblanchet is one of a new breed of archaeologists who draw from still-living traditions among the rock painters of Arnhem Land. In selected caves in the south of France, Leblanchet recreates prehistoric images using only the tools and pigments that were available to the ancient artist. Working in dim light and using techniques learned from Australian Aboriginals, he first uses a piece of charcoal to sketch a rough outline of a subject on the uneven cave wall. Then, Leblanchet uses his mouth as an effective paintbrush, first grinding the charcoal in ochre with his teeth, and then gently spitting it onto the outline. He uses his hands to guide the flow of the primitive paint. The techniques he uses are ancient and are probably similar to those our ancestors used thousands of years ago.
Yes. The breath is probably, I think, the most important part of a human being, and the artist, by spitting the paint, is projecting himself onto the rock surface, and during this action he became a horse. He was transformed into a horse.
When you look at the rock art, it was painted by the hands and the emotions and the mind of the artist that created it. To witness what the ancestors left behind is an incredible gift.